All right, guys. In this video, it might be two or three videos. I'm going to be going through the 2018 free response section on the AP exam. Um, so remember, after the AP exam, a couple days after the AP exam, they release the free response questions, and so we're going to use a lot of the old free response release tests for practice exams, but there's a couple exams that I'm going through and actually just, showing you a video of me going through the test, showing you the answers, how to think about things. Just, as you're prepping to take the AP exam, half the battle is, being able to take the test quickly, know what to look out for. And so if you do enough of the different release tests, you'll start to notice like similar things. And the big part of being successful at this test is not necessarily all the chemistry. It's really just cutting through all the information that's given in a question and finding and simplifying it and figuring out what the question's really asking. Because you'll notice, like sometimes you'll see charts that maybe you haven't seen before or different things, and a lot of that's there designed to distract you, and sometimes it's just an oxidation question. Hey, what's the oxidation number, or what's the limiting reactant, or what's the order of this reactant in kinetics or something. So that's kind of half the battle. So depending on how long it takes, each video will be about 25 minutes or so. So as we approach the 25-minute mark on this video, if we haven't finished the test, then we'll move on to another video and so on. So, but again, this is the 2018 FRQ free response portion of the test, and you can get a copy of this in Schoology if you want to follow along, and also you can get a copy of the key if you want to follow along as we go. All right, so let's dive into it. All right, so let's remember, on the free response section, you're going to have 105 minutes. Okay, so an hour and 45 minutes to complete a total of 7 questions. Remember, there's always 46 points that you can get on the free response portion of the exam. The first 3 questions are each worth 10 points. So out of the 46 total points you can get on the free response, 30 of them are in questions 1 through 3. Okay, question 1 is going to be worth 10 points, question 2 is going to be worth 10 points, and question 3 is going to be worth 10 points. The last 16 points are questions 4 through 7. Okay, they suggest you spend about 20 minutes, okay, on each of questions 1 through 3. So 20 minutes on question 1, question 2, question 3, and only spend around 10 minutes, 9 to 10 minutes, they say, on question 4, question 5, question 6. Right, and again, think about the points. They're only worth 16 points. Okay, so your goal is, hopefully, you get a perfect score. But remember, a 78% could be a 5 this year. 75% could be a 5 this year. So the top score, whether you get 100% or an 80%, is a 5. So you want to maximize the points you can get. So you want to go fast. If it's something that you don't recognize, then skip it. If it's something where you need an answer in part A so you can answer part B, but you don't know how to do part A, make something up, put it down, and then use it in part B correctly. You can get credit for reading down. And a lot of times, these last 4 questions, 4 through 7, especially when we go to number 7, you're going to see how easy it is. And a lot of kids aren't going to get those 4 points in number 7 just because they didn't get to the question, not because they don't know the chemistry. They know how to do it. They just spent too much time on question 1. So, you want to spend a good amount of time on questions 1 through 3, because again, we're talking 30 out of 46 points, and you want to try to make sure you get as many of those points as you can. But you also want to make sure you're moving fast enough that you read every question, and especially in 4 through 7, some of those questions you can just answer very quickly, but you're not going to be able to if you don't get to it. All right, so let's go to question 1. Notice it does say, pay attention to significant figures. And also, I guess, real quick before another thing, right? You get a formula sheet, you get a periodic table, so you'll have this, so you have all your formulas. So, make sure you know how to use them, right? So it says pay attention to sig figs, but they're not going to take points off for sig figs unless it mentions sig figs in the question. So if we stumble upon one of those questions, we'll make sure we highlight that. But you shouldn't just go crazy with it. And, when in doubt, I'd say just round to 3 sig figs. But, you should be able to do your sig fig rules and just try to be like, oh, okay, it looks like, like if we look at this has, this right here has 5 sig figs, but that only has 3. And like all of these have 3 sig figs. So probably in this question, any of the calculations I'm going to do, 3 sig figs, right? And as long as it doesn't say like, make sure, like in this question, make sure you have the right number of sig figs or something, then, if you accidentally round to 2, you'll still be in good shape as long as you show kind of what you're thinking and what your calculation is, all right? So again, let's go to question 1. And if we look at question 1 is A, B, C, D, E, I, F, G. All right, so we got A through G here, and E has 2 parts, right? So all of the stuff on this page and this page, can be kind of called upon on question 1. So there might be a piece of information right here in this balanced equation that we need for part G or something. So, make sure you understand that it's there. And also understand that this is no longer the way the test is going to be formatted for you. On the new test, they put a lot of room between A and B so you can write your answer. A lot of room between B and C so you can write your answer. This older way from 2018, it's not that old, but this older way is kind of there. The way it used to be, and what you would be doing is writing your answers in a blue book on blank paper, kind of like the way we do our unit tests. But now there's going to just be room in the question. So question G is on the second page, but if this were formatted for the current AP exam, question G might be on the 6th page. So watch out for those things. All right, so let's go into question 1. Right, we got this big equation. It's already balanced for us. They got their coefficients there. And a student performs an experiment to determine the enthalpy change of delta H. So we're probably thinking about calorimetry data, and maybe we'll have to calculate the delta H of a reaction. So making sure, back from unit 3. But question A just says, determine the oxidation state of chlorine in sodium hypochlorite. All right, so that's easy enough. If we go to part A, we would give the sodium a +1. We would give the oxygen a -2. And that means the chlorine in this case would have to be a +1. So the oxidation state of chlorine in the sodium hypochlorite ion is +1. Okay. Calculate the number of grams of sodium thiosulfate needed to prepare 100 milliliters of a 0.5 molar solution of sodium thiosulfate. All right, so this is just kind of dimensional analysis. We need to take liters in molarity and get to grams of solute. So we would take our volume in liters times the molarity That would give us how many moles of thiosulfate. And did they give us the molar mass? No, they didn't give us the molar mass. So we'd have to calculate the molar mass of the Na2S2O3 compound. So that's what that is. That's the molar mass of this compound. So, you know, you might not have calculated molar masses recently in this course. So go back, you know, so 2 sodiums, right? You'd be referencing your periodic table. 2 sodiums, 2 sulfurs, and 3 oxygens. Okay. And we would just, liters times molarity gives us moles of the solute times the molar mass gives us grams. So we would need to measure that many grams of the salt, dissolve it in a volumetric flask that's 100 milliliters, and that would end up being our molarity. Okay. Oops. All right. So where are we? We're at part C. All right. So we have this table. Notice again we have the balanced equation, so we have all the coefficients we need if we're going to do some stoichiometry. Using the balanced equation for the oxidation reduction reaction and the information above, determine which reactant is limiting. All right, so we started with equal volumes, equal molarities of these things, so it really comes down to the mole ratios. So we had equal moles of everything, but you know, if we let's pick water. You know, you could pick any of the reactants, or sorry, the products, but you know, 1 mole of this will produce 1 mole of water, but 1 mole of this times 1 over 4 would produce, you know, 0.25 moles of water. 1 mole of this times 1 over 2 would form a half a mole of water. So if we have equal moles of all these things, this would end up being the limiting reactant. Okay, so what did I do? I did liters times molarity for each thing, and then I multiplied by our mole ratio. But I went to sodium sulfate, so I was doing stoichiometry and figuring out. Whoops! Hold on. Okay, so I was doing stoichiometry and I was figuring out how much of this product was being produced. So, you know, I took my moles of this times 2 over 1, took moles of this times 2 over 4, and then took moles of this times 2 over 2. And whichever one gives me the least amount of product is going to be my limiting reactant. So that's the kind of thought process I was going here. So if you do the stoichiometry for each one, this is the lowest number of product I can get. So that was my justification. These are my calculations here. And I know that the sodium hypochlorite in this scenario is the limiting reactant. Okay. And so kind of these calculations and this little statement right here, that's my justification. All right, so we go to the next one, part D. So we're still talking about the same one. The solutions all at 20 degrees Celsius are combined in an insulated container. So our calorimeter, the temperature of the reaction mixture is monitored and as shown on the graph below. So here is the temperature, okay? So notice the temperature goes up. So immediately we know, remember this is the temperature of the surroundings, so we know it's exothermic because the only way the temperature of the surroundings can increase is if the reaction is releasing energy to it. So right off the bat, before I even read a question, it's an exothermic reaction. Delta H would be negative. Heat is a product, all that stuff. Okay, so according to the graph, what is the temperature change of the reaction? So we just have to, you know, find this temperature. That's right in the middle between 32 and 33. So probably 32.5 is our final temperature, and our initial temperature was 20.0. So all we have to do is 32.5 minus 20, final temperature minus initial temperature, and that's our temperature change. Let's see if we did it. Yes. And your estimate might be a little bit different. You know, if pretty much in the middle, I would go with 0.5. Now, they didn't say anything about sig digs, but this is where I would watch out, right? The chart, right? Based on the chart, I can go to a single decimal place. And remember, when you subtract or add, but in this case subtract. It's not about significant digits, it's about decimal places. So we're allowed one decimal place in our final answer there. But that wasn't a thing mentioned in the question, so it's not really that much to worry about. All right. The mass of the reaction mixture inside the calorimeter is 15.21. So they give us the mass because if we're thinking calorimetry data and figuring out a Q value, we're probably going to do Q equals MCAT, so we'll need the mass of our solution. Calculate the magnitude of heat. So magnitude means absolute value, basically. So yeah, the delta H should be negative if we want to report a delta H for the reaction. If we look at part 2 here, we need the delta H, so we're gonna need to know that this is negative, okay? But up here, we're just calculating the magnitude of heat, so it doesn't matter if it's, you don't have to make it negative here. So calculate the magnitude of heat in joules that is released during the reaction. Assume that the specific heat capacity of the reaction measure, so they give us C, and Q equals MCAT, and that the heat absorbed by the calorimeter is negligible. So that means ignore the calorimeter. So all we're going to do is Q equals MCAT. Here's our mass, and here is our heat capacity, and we calculated our delta T in part D. All right. So we just plug in everything. So 749 joules would be our answer for E1. Okay. So now E2. Now we have to actually calculate the delta H of the reaction. They want it in kilojoules per mole, and we want the correct algebraic sign. So this is where it pays off to recognize that it was exothermic. But remember, whenever you do Q equals MCAT with calorimetry data, and then you're trying to figure out the heat change of a reaction, you always flip the sign. So you do Q equals MCAT, that's always for the surroundings when you're using the temperature change in the data, and then you flip the sign of Q. To get the correct sign for delta H. So we ended up with a positive Q here, so we flip it to negative. And we wanted energy per mole, but this is, so remember, NaOCl was our limiting reactant. And if we go back to the, oops, hold on. Okay. So if we divide by how many moles of our limiting reactant, we got that, and also divide by 1,000 to get it kilojoules per mole. That's going to give us kilojoules per mole of the sodium hypochlorite. But if you go to the balanced equation, 1 mole of the reaction consumes 4 moles of the sodium hypochlorite. So we need to multiply this by 4 because 1 mole of the reaction has 4 moles of sodium hypochlorite, right? In dimensional analysis, you wouldn't have to really show it using dimensional analysis, but maybe you'd have to know that this would be energy per mole of that compound in the reaction, and if you want energy per mole of the reaction, you'd have to multiply by its coefficient. If its coefficient was 1, this would be our answer, but since its coefficient is 4, we have to multiply it by it to get energy per mole of reaction. So it ends up coming out to be around 1,200 kilojoules per mole, but you have to make sure you make it negative because it's an exothermic reaction, okay? All right. And, oops, all right, so we're here. Okay. So the magnitude of the enthalpy change in delta H in kilojoules per mole calculated from the results of the second experiment is the same. Explain the result. Okay, so the student repeats the experiment, but this time doubling the volume of each of the reactants as shown in the table below. The magnitude of the enthalpy change calculated from the results of the second experiment is the same. Explain the result. Okay, so remember, the delta H of reaction doesn't change. So in this experiment, what would happen is more moles of this would react, so more energy would be released, the temperature change would be greater, but when you ended up dividing by how many moles react, right? You'd be taking your energy value, dividing it by, which is larger than the previous trial, but then you would be dividing it by moles, which would be larger than the previous trial. And so everything would come out to be there. So more heat will be produced as more moles of reactants are consumed. However, the ratio of heat per mole will remain the same. Okay. So that's our answer for part F. And then write the balanced net ionic equation for the given reaction. So they gave us the reaction. So this is where we're going to have to, here, we're part G of the question and we need this, right? And they give us everything we need, right? All of these are aqueous ionic compounds except for the water, right? And so aqueous ionic, you separate. So this is 2 sodium ions, 2 thiosulfate ions, 4 sodium ions, 4 hypochlorite ions, 2 sodium ions, 2 hydroxide ions. This would be 4 sodium ions, 2 sulfate ions, 4 sodium ions, and 4 chloride ions. And so sodium's going to cancel out. Sodium's a spectator ion, and then everything else is there. So that's how we're going to write our net ionic equation. So notice we have all the ions in there and water except for sodium, because sodium didn't change the whole time. So that's our net ionic equation. Okay. All right. Oops. All right. So, all right. We're coming up on 21 minutes. So I'm going to stop this video here. So that was only question 1. The next video will start right in for question 2 and keep going. All right. So let me stop that.